Hello, everyone. Welcome. Hey. We are thrilled to be with you today. Thank you for being here. I know it's not easy to come here. It's not in the main conference center, so thank you for that. Thank you for picking us. Before starting, I have a question for you. Do you know which platform can offer VR experience that you can write only once and deploy and use everywhere? Unity works almost, but not for the web. Say you want to reach the browser, Unity, that's not a good answer for that. So obviously the answer was WebVR, and that's why you're here. I hope you were not expecting a Unity, right? Then we're gonna have an issue else. My name is David Catu. I am here with David Rousset.
Hello.
We are the David. We are working on Babylon.js. It's gonna be I would say the foundation of this talk. So welcome, and let's get started.
Yes, and I would like to know how many of you are game developers in the room? Okay, interesting. We were expecting more. So it's great because most of the time people think that web, VR, and 3D in a general manner is to build game, but we're going to show you that using the technologies that we've been going to use during this session, we'll be able to use very useful application and scenarios, even for serious stuff.
Let's call them experiences, right?
Experiences.
Yes. OK. So WebVR stands for Web Virtual Reality. Easy. It's an open standard, OK, that it's maintained by an independent group where Microsoft, Google, Firefox, we are all part of this group in order to provide a unique way to reach out specific headsets that you have here on the slide. So whatever you want to use, Oculus, and now I just added the Oculus Go, which is here. It could be Daydream, it could be HTC Vive, it could be obviously Windows Mixed Reality headset. WebVR is the way to reach them.
Yes, so you're talking about devices, but we now need to talk about platforms. So today there is two main platforms that you can use to develop and address people with WebVR. The first one is Windows with various different browsers like Microsoft Edge, which got out-of-the-box support for WebVR, like Firefox, which got an out-of-the-box support. Chrome doesn't have it yet enabled. It's currently under a flag, or you can use a specific Chromium build to have it. Just a small detail, you see that if you're using Microsoft Edge, you will be able to use the Microsoft mixed reality headsets. Rather than if you got an HTC Vive or Oculus, you will need to use either Firefox or Chromium. So this is for the Windows desktop part. On the mobile world, you need to use Android, which got support for all of the small headsets, I would say, like the Gear VR, or also the latest one like Oculus Go. And there is a beginning of support on Mac too, but most of the people today are using Windows and Android.
Yep, and that's about platforms. The main issue you may face is that WebVR is not an easy specification. It's a good tool. It's a good way for you to reach out any devices out there, true. But the way to deal with it requires some mathematical knowledge and understanding on how a rendering pipeline works. That's why most of the time, unless you want to write a specific 3D engine, you will use a framework. If you have a question, yes? OK, so I'm going to repeat the question just for the recording. The question was, mixed reality headset, does that include HoloLens? And yes, sir. Since RS4, HoloLens is also a WebVR-capable device.
It's behind the flag,
by the way.
It's not activated out of the box, so you need to go in About Flags and activate WebVR.
So frameworks, why frameworks? Actually, just because it's not easy to deal with the spec directly. So out there, you can find mostly two frameworks. The first one, A-Frame, comes from Mozilla. It's based on top of 3JS. And the second one, it's the one we will use today. It's Babylon.js. And I guess we should just jump to Babylon.js slide. Just before going to Babylon.js slide, one single point of, I would say, vocabulary and future reading here. WebXR. You may have heard of this word.
Yes, so you've mentioned HoloLens, like it's an augmented reality device in a way, even if we call that mixed reality in our case. But WebVR, currently in 1.1, that we are supporting in Babylon and most frameworks are supporting, was obviously made for virtual reality. So it means that it's not easy to switch from something that's being built for a virtual reality to something else like augmented reality or even mixed reality. So WebXR is designed to address both scenarios and will be designed differently.
Yes.
The first iteration will start by concentrating on parity with WebVR, meaning that we're currently working on it. Microsoft and Google and Mozilla are working on it. And the first version that will ship by the end of a year, maybe in a couple of months, will first be like a parity with WebVR. But the design of this specification will enable, in the future, cross-platform AR by using specific feature inside it. It brings also simplified and unified input models. So as framework creators, we know that. It wasn't simple to address all the different controllers like those one or the gamepad. And the gamepad API wasn't really made for that. So they're going to change that at the specification level. And we will be able to address like all the 6 degrees of freedom controller that we're using today, the 3 degree of freedom like the one from the Gear VR or the Oculus Go, and also hand gesture on whatever we could imagine in the future. Pay attention that WebXR is different from OpenXR. So WebXR is really at the browser level, whereas that OpenXR is at the driver level, which doesn't mean that people could build WebXR on top of OpenXR, but this is not mandatory. This is 2 different specifications.
So perhaps next year at Build, we will have a talk about WebXR and not WebVR anymore. We'll see. So going back to the framework, yeah, the idea here is to give you tools that you can leverage almost immediately and then start working with VR. Babylon.js is a 3D open source framework based on top of WebGL 1 and 2. Sorry about that. We have a specific booth at the expo level, so if you want to swing by, we have multiple computers there where you can try it and play with it. We have multiple computers as well with headset connected, so you can literally play with it if you want to. It was created since the very beginning as an open source framework. It was one of the first open source frameworks that we literally created entirely as open source, meaning that there is no internal at Microsoft repo that we then duplicate to an external repo. We are doing all the work on the public external repo, meaning that the roadmap is discussed there, bugs are fixed there, etc. It's based on an Apache 2 license, which is the do whatever you want with it license. It's also community-driven. So obviously, as Microsoft, we are using it in a lot of first-party applications like Remix 3D, Xbox Avatar, Bing, Visio, Dynamics, PowerPoint. So we also have feature requests coming from this project. But they are all exposed in a way that the community can come and say, hey, we really want to focus on this one first. So the roadmap is clearly community-driven and built. It's written in TypeScript, good news. So how many JavaScript developers do we have in the room? Okay.
And how many C# developers?
Yeah. So for C# developers, and actually even for JavaScript developers, you like types. Me too. We love types. So that's why TypeScript is clearly JavaScript plus types, and that's why we use TypeScript here. Obviously, if you just want to use vanilla JavaScript, not a big deal, because the TypeScript compiler at the end generates, obviously, pure JavaScript. So you can have both, which is really cool. You can have entry and insert for the same price. We are also proud to work with external partners like Adobe, Sony Electronics, Ubisoft that are using Babylon.js internally or externally for public-facing projects. So it's a project that you can trust. It's not something we started last week.
And
Why
you may,
Babylon then?
Yes, you may ask yourself, why should I choose Babylon.js? So first of all, we're spending a lot of time in backward compatibility, meaning that we really try not to break anything. If you're switching from version 2.5 something, for instance, to the latest version, we try really to keep compatibility and really being true cross-platform. What I mean by true cross-platform, we all know that today, sometime on the web, people are not really testing on whole browser. We know you, we know us also, sometimes we are lazy. But I really think that the beauty of the web standard is that it should run on every browser. And even if the specifications sometimes is hiding a little bit of detail in the implementation, we are taking care of that for you. So we're going to spend a lot of time testing on iPhones, Android devices, Windows devices, and all different browsers on desktop and Mac for you. So it's really important. Also, our philosophy is that every developer should really be very quick. It should be very simple, having one line of code to do something really interesting. And it's going to cover most of what you will need. And this is something that we decided at the beginning because we know that not everybody should be 3D gurus when they want to build 3D scenes. Still, this is a challenge. Having simplicity in mind, keeping high performance, this is our job. Or this is the job of this guy, who is really an awesome guy in shaders. So this is a mission I gave him at the beginning. So far, it's been good. And we have also a lot of tools we're going to see together in the demonstration. Features, whatever the feature you will need, you should be covered by the engine. So we have a ton of them. Could do a WebRTC, WebVR, obviously. We have a collision engine embedded. We've got support for gamepad, audio in 3D, PBR, animation, physics engines. Well, whatever you want to build on the web, we should have that out of the box. And this is part of the main project, meaning that, for instance, all those different features are maintained by the core team.
Right. So we don't want to focus on all the features, obviously, but more on 3 of them that are really important when you want to create a VR experience. First of all, you need to provide a good-looking rendering, like something that is appealing, that works pretty fast, because remember, for instance, the Oculus Go is a pretty small handset. It's like something around the S7 from Samsung, if you look at the power of the GPU. That should also, the same scene that you are working on should work on these small devices to the big computer with a 1080 card from NVIDIA. To do that, we provide you the PBR. The PBR, for physically based rendering, is a technique used and invented by Disney at the origin to simulate the real world. The PBR is a way for the 3D engine to represent something that exists in the real world. It's based on complex equations, on complex optics equations that are completely hidden for you guys. You can just say, OK, this object will be rendered with PBR. I want it to be a little bit glossy, not too much metallic, and I want a little bit of roughness on it, and that's it. You declare real-world properties, and then the shader will internally compute the equations for you and render something that looks realistic. OK?
Great.
Second stuff that we need.
Yes. So when you are in WebVR, I don't know if you know how many of you know WebGL in the room? So some of you don't really know maybe what's WebGL. WebGL is being rendered inside an HTML5 canvas element. And when you're building 2D, I mean on 2D screen, 3D experience, you can put the canvas somewhere in your HTML page and put some DOM element on top of it, like checkbox. Let's imagine you want to do a car configurator tool. You will have the car in 3D, and it's going to change the color using specific HTML elements. So far, it's perfect. If you want to switch inside...
Sorry, I'm smiling because I'm reading the automatic translation.
And I'm not speaking very good English.
No, that's fine. That's
okay.
fine.
And when you're switching in VR, we're going to take this canvas and put that full screen, which means that you won't have any more HTML elements being rendered. So if you want to have like buttons, checkboxes, stuff like that, you need to render that in 3D, in the canvas itself. That's why I've asked kindly to my friends to build a new layer, a 2D layer inside the 3D space, which is named the GUI. that gives a control that's going to be rendered in the 3D world, so you will be able to use it with the mouse or touch, but also with a controller in VR.
Yep, we're going to see that in the demonstration later. And obviously, you need PBR, you need GUI to build your UI, and obviously, you need WebVR. That's going to be available outside of the box as well. So we support completely WebVR 1.1. We are writing right now a WebXR support as well, so hopefully as soon as WebXR will hit the ground, we should be able to provide something for you guys, always with backward compatibility in mind. That means if you start today with WebVR, the day WebXR will become public, you should have to change just one line of code, moving from a WebVR camera to a WebXR camera. Also, interesting point, which is really important as a developer, when you are creating your environment and when you are developing, you may not want to always spend too much time inside the headset. That's not something easy for developers. Also, you want to create an experience that works well in VR and not in VR, because not everyone has a VR headset connected to the computer. That's why we provide for you this fallback named the Device Orientation API. When you are rendering something which is ready to be in VR, if there is no VR-capable devices, then the system will automatically fall back to a Device Orientation API, meaning using like your phone, for instance, we will use the orientation events to simulate 3 degrees of liberty VR, okay? So even with your computer, if you have a Surface Book, for instance, you can just do that and see if your work is working correctly, okay? Obviously, we support all the major headsets out there, including gamepad. So now let's stop talking, actually, and start doing some demonstrations, okay? The goal, we will do 2 big demos, and the goal is clearly to drive you through the, I would say, the journey from nothing to a complete WebVR experiences, okay? So let's switch gears.
Thank you, David. So we've got this beautiful 3D scene. Maybe you can have a look first on how to load it. So this is few lines of code. I was trying to explain you that. We're going to load this scene from the web server, obviously, and I'm going to put the camera just in front of the main door.
Perhaps, before going further, just mentioning the environment. This environment is the BabylonJS playground. You can find it on playground.babylonjs.com. It's a website. With on the left, the same engine used by the VS Code. It's the Monaco editor, so you can type, have IntelliSense, and everything in JavaScript, but with typings, like right now with IntelliSense, and you can even have documentation without nothing else than just your computer. Actually, if you are a little bit brave, you can even do that on your phone. You have to be a lot of brave, but yes. Anyway, then on the right, when you click on Run, you will see exactly the execution of your code. If you're OK with what you have, you can share it and save it with the Save button that will generate a unique URL that you can share with your friends, representing the current state of your code that could evolve, obviously. And finally, you can also download a complete project set up for you with the Zip button. So no need for setting up anything. Obviously, you can then go to VS Code or Visual Studio to prepare your project. But at the very beginning, you don't need anything else than just a browser.
That's why we will do everything inside the playground. And at the end of the session, you will have a URL when you will be able to download all of them, check it out at home if you want to replay the session at home. So this scene has been made using 3D Studio Max. We've got plenty of exporters from Blender, Max, Maya, Unity. We can even export from Unity, but the 3D models only, not the code. And now let's see how to transform that to a VR experience.
So remember, the foundation of BabylonJS is one line of code should be one feature. That's exactly the point here. David will go to the list of function provided by the scene itself.
So there's one named Create Default VR Experience.
Yes.
That could have a various option. I'm going to use the default one. And by pressing the Run button now, I will have a button that's going to be displayed at the bottom right. Because to enter WebVR, you cannot do that automatically. You need to use a specific user interaction.
Correct. That's per spec requirement.
Now, if I'm pressing this button, you see that I'm going to enter VR in the mixed reality portal that got access to my HMD. And if I'm moving the headset in various directions, I have the first level of VR experience, which is the most simple one, which is like a 360 experience. Like it's not a 360 video, it's a complete scene rendered in 3D. But maybe it's enough for you. Maybe it's enough to like discover something moving around you that could interact with you in an automatic way.
So literally, you can ask your designer or someone to create a 3D object or a 3D environment, load it, call this create default VR experience, and you're done.
Exactly. I'm going to switch here. And I've lost a stage. So don't worry.
Be happy.
Yes, that was the demo I wanted to do.
Should be good.
OK, so if I'm going back to the browser, and I'm going to refresh that. For first demo, first fail, everything is under control.
I'm pretty sure it is. You could have clicked on save, and then...
It's right, but it's pretty fast to type. Create default VR experience, and I'm going to click run.
And the button is here.
And the button is here.
Let me switch to here so people can see it. It's going to be easier. So
it's there.
Yes.
So you've seen that we've been downloading for you the model from our CDN. Because it's a mixed reality headset, we took the model exactly from the Samsung. You see it's a little bit different than the classical one. And if it was an HTC Vive, it would have been the HTC Vive or the Oculus, whatever. So it's the first experience, very simple to do. Now let's say that I'm going back there. I don't know if you've seen, but my mouse cursor is different, which means that I have interactive element in my scene.
So when you click on this object, you see there is a small, tiny animation. We should have sound. Yes. It's going to be even better.
Yes, because I don't know if you don't have sound? No.
It's OK. When you click on it, there is this animation, plus a wow!
Yes. So every sound will be done with our mouse now. So what you need to do is to take the helper object, keep it, and on it, I'm going to type enable something, and I've got an enable interaction method, and I'm going now to click run. The difference between now or just before is that now I will have the controller that will be automatically configured to be able to, yes, can you please click?
I'll do that for you, no problem.
Thank you. And
so what you see on the screen is what David is saying, obviously, and that's VR, WebVR, sorry. So it's rendered by Babylon.js.
And now if I'm putting the laser pointer of my controller on top of this element, I see that it's changing. In bit, can I activate it? So using this, I don't know if you can see it, the trigger, so it's being animated. So I can now click on it.
Don't move your head too fast, because we are going to all throw out.
OK. And now you can see that I've been able to activate that in VR.
It's motion sickness at room level. I loved it. Motion sickness at scale.
Yes, sorry for that. So this is the first part. So this scene wasn't made for VR in mind, but
no.
As soon as you make it compatible with a 2D interaction, like a mouse or a touch, we are going to handle that for you because we are simulating pointer event under the hood.
So that was for interaction with the environment. We also provide interaction with UI, and that's going to be the next demonstration.
Yes.
So David mentioned the UI element that we had before, and the fact we cannot use DOM element because when you are in VR, there is no more DOM, there is just the VR world. That's why you need a 2D user element that could be projected into the 3D world. And that's exactly what you have here. So David can select option, and you can see it's in 3D. There is a color picker that changes the color of the sphere right there. And this is 3D that work with mouse, touch, pencil, and controllers. So that pointer event plus plus.
So to make it compatible with VR, we just need to have the same kind of code and add the 2 lines of code we've seen together at the beginning. Those 2 lines of code, so still the same one. I'm going to remove the helper, and you see. And now by doing that, so I need to enter
I'm going to do
VR.
that for you, no problem.
Thank you.
So let's switch to the mixed reality portal right here.
And now you see I can activate the different options using my controller, and I can also change the color picker, and we've got a pointer move and event being handled for you, and you're ready to go, and you can imagine configuring a car like that completely in VR inside a web page.
And as a developer, the important point here is that you can do everything with your mouse. If it works with your mouse, then it's going to work in 3D in VR mode. Obviously, you have to test in VR, but you don't have to do all the entire development cycle in VR, which is the important point here.
So the last demonstration from this demo run.
So we did interaction, but now we also want to move, right? You want to also wander around, navigate, discover this wonderful mansion with no sound.
Yes, but it could be a museum, for instance, or a virtual tour. And now if I'd like to move in VR to move, I don't know, you probably know that, you shouldn't move like in an FPS game using your gamepad because you will probably be sick. So you're using teleportation. And we decided to work with the people building the mixed reality portal to really copy-paste the behavior, like the animation timing. We are going to reduce the field of view when I will teleport. To enable teleportation, there is a function named enable teleportation. You need to provide the name of the floor, and in our case, floor in French is allée.
So the designer who created this mansion was French, and he named the ground object allée, which is ground in French.
It was to test Unicode, you know.
Yes, and we support accent, so proud of that. So if you create a scene, you just have to specify which object name is the ground, is the floor. So where should we stand?
So now let's switch back. And I can still activate the little button over there.
Don't move your head too fast.
If I'm rotating right, using the button, I've got 45 degrees rotation or left or right, like in the mixed reality portal. If I'm pressing forward the button, I can now have a teleportation target. If I'm releasing, I'm going to be teleported with an animation. And I want to visit this part of the scene. And you see we've got Hamlet. So I can activate Hamlet because unfortunately he's dead.
His head, yes.
I don't know if you remember Clippy.
Clippy is dead.
And Clippy is dead.
We found him, he's just right there.
Yes, and Clippy is now living in the VR world, in VR space. And also we've got the Schrödinger cat. We never really know if it was dead or not, so we decided that it's now dead. So it's very fun to do, but you can imagine a lot of different scenarios using the same kind of approach.
Right. And we mentioned also the fallback. And let's start Chrome. So far, Chrome, the Chrome that we have, does not support WebVR yet. It's under a flag. So it's going to be a good test for us to get a browser with no VR capabilities. And if David clicks on the button, this time the system will just go full screen, expecting that you use that as a cardboard devices, so you can put on your cardboard, and like with your phone, like that. And then when you move, it's going to get the device orientation events to simulate the VR for you. So with the same code, you can also support cardboard. So this device here has no device orientation, so I won't be able to move it, but you get my point.
Just pay attention then to the UX parts. I was able to teleport in my scene. If the scene is made to have teleportation, think about that with cardboard. Maybe you should look at specific teleportation targets with a timing approach. You need to maybe adapt a little bit the code for your own experience. This is done by the engine, but we cannot know what you would like to do inside your own experience.
Thank you, David. So what we did actually, we wrote 3 lines of code. Most of the work was done by the designer to create the scene itself. But if you look at the code, we just create a default VR experience object, and then we can turn on interactions, and we can also turn on teleportation. And you can do both or none of them, okay? And cross-platform, it's free. You can run it on Oculus, HTC, anything that's gonna work. Cool. Second demo, this one is gonna be a little bit more, I would say, complete. David had this idea to write a game with you. So he loved the game Fruit Ninja, you know, when you receive fruits and then you have to cut them with, with the touch. So obviously, cutting them with the touch was not that fancy, so we decided to use lightsabers.
The most powerful weapon in the universe.
Yes.
Yes, I think so.
So we're gonna create lightsabers with you guys, and we're gonna cut apples.
Nobody will be hurt during this session.
No fruit. I don't think so. So, I'm gonna switch here.
Yeah. And you're going to work a little bit.
I can't just talk. So we are not designers, we are pure developers. So that's a problem when you want to create experience. If you are lucky enough to have a designer with you, cool, that you are really lucky. If you don't, we have options. For instance, at Microsoft, we provide Remix 3D website. It's a free website where you can find tons of 3D models for free that you can use in your own developments. For instance, David found this wonderful apple. So just to mention it, the website here run on Babylon.js to render this stuff. So what you see here will be what you get also in your own experience, okay? So we have an apple here, pretty good. And let's find a kind of lightsaber. For some reason, I guess there is a trademark on lightsabers. So this one is okay. Wonderful, right? What can I do with that? The option is to go through Paint 3D here, that you should have on your computer if you are running Windows 10. And by clicking here, Paint 3D will download the asset from Remix 3D and let you play with it. Actually, I just wanted it to just save my 3D model as GLTF. GLTF is a wonder. GLTF is my best friend. I have been working in 3D since almost 25 years, and the only problem that was really hard to fix was file format. Like, there are thousands of different file formats, all proprietary. Some people try to do something with open file format like Collada. It was okay-ish. So at some point in time, someone said, hey guys, we should just all talk and define an open source file format. Kronos did that, that's GLTF. Microsoft is an important member of this consortium. We are working with people like NVIDIA, like big names in the 3D world to make sure that we have a common language. I would love that everyone speaks French here. That's gonna be easier for you. And for me, actually, as well. GLTF is like the English of the 3D. It's the JPEG of the 3D. It's the common language that anyone understands. So here, Paint 3D can generate a GLTF file. You can then take this GLTF file, drag and drop it into Facebook, open it into Unity. That's the wonderful world of 3D when there is just one single language. So here, Paint 3D will generate for me a GLTF file. So there is GLTF and GLB. GLB is a GLTF plus texture and all assets into one single file. So let's call it Saber. Okay, saving, waiting for saving. Yes, perfect. In the meantime, no, that's okay. I'm gonna show you the sandbox. The sandbox.babylonjs.com is another website. So the first one we showed you was playground.babylonjs.com. Now it's Sandbox. The Sandbox is a tool mostly for designers or people that want to test assets. Okay? Here, I can just come with my exported file, which is here, drag and drop it, and I can see it rendered by Babylon.js. Okay? So that's what you can get inside your own engine when you're gonna use it.
And I've got a question for you, David.
Yes?
I know this model, and it's like a toy, and the cyber part, the green part, is too small.
Yes.
I would like to stretch it or to scale it.
You can edit the object, obviously, using JavaScript when you are running in your own code. But the sandbox is also interesting here because you can do some quick prototyping. Here, I'm going to open the list of meshes. So the Saber is not one unique mesh. It's multiple mesh. And there is one that is interesting for me, the one that you mentioned, which name is node_ID32, which means Saber, but I don't know in which language. In designer language, that means saber. So I can see it's this one because I can hide it and display it. And you mentioned the size of it, and size matter. So let's go here and change the scaling of it. You can edit dynamically the value of any property. All the properties here are JavaScript properties that you will find when you're going to be in your development environment. So here I'm going to switch to 3. So it's going to scale on the y-axis like that. And obviously, because I scale it a little bit too much, I'm going to also change its position. And you can see there are tons of properties. And I'm going to switch that to 130. And this is my object, OK? And then I can go and ask the system to save the GLTF for me if I want. Once I'm good with my asset, then you're going to create the game.
Yep. So now we know how to get some assets. We're going to see how to load one of them and to start building the game. So we're going to start the game first in 2D, like we've seen previously. So this is the game. So we can...
Disclaimer, we are not designers.
Yeah. I'm going to put that full screen. And there should be music. I've been composing the music for IP reason. And the first part is I can click on the apples, and I'm going to destroy them.
The sound is in the headset.
The sound is in
I hear it.
OK. So very simple game. I've got a menu. I can stop the game, and I've got some particle when I'm destroying the apple. So this is the first part. Just to see how it works, very simple. The first, we're going to create the skybox and the light.
Which is this blue stuff. It's important to not be on a dark background because you don't have a feeling of the 3D and the depth.
So there's a small gradient.
Yes.
We're going to load the sound, which is the sound when I'm going to kill the apple and the music. And we're going to import the fruits. So if I'm navigating to this function over there, I'm going to change the font. It will be better to see what's going on. I'm going to import the mesh. And I'm going then to take this mesh and to duplicate it using instances. So if you're not good in 3D or if you don't know yet 3D, it's better to create instances that are going to live in a GPU world rather than on the CPU side for performance reason. It's going to avoid to have a lot of different round trip between the CPU and the GPU. And in VR, it's important to keep the performance at a high level because otherwise people will become sick.
The target frame rate when you are in 2D is 60 frames per second, but in 3D, when you are in VR, it's 90. So depending on the target device that you want to run your simulation on, it could be touchy. Like the Oculus Go is an excellent example, pretty good device, but with limited power, mostly on the GPU. So creating instances is a good option to start optimizing early. There is a question for... So when you are, the question is, can we do more than 60 on the browser, right? So when you're on 2D, actually the browser will call you 60 times per second. But as soon as you enter VR, the browser will automatically call you at 90 times per second. So if he can. So if you are rendering the entire city of New York in 3D, then even if the browser is really motivated, it's going to be tough for him to call you 90 times per second.
Request animation frame is going to be called differently. And we're going to create the UI and the special effects. So as I told you, now that I know that it's working in 2D, our motto is that you should switch to VR in a very fast way. What we haven't seen so far is how to switch the default controller model to the famous laser saber. So we're going to see first how to do that with another sample, how to switch the controller. So let's see how it's going to work, and we will see the code after that.
I'm going to click for you if you want.
Thank you.
Right, cool. You're good.
So you see I've got the default controller model, could be the HTC Vive if we're using an HTC Vive. When I'm going to click on the button, it's going to replace them by the laser saber I've been loading, and it starts to be cool.
Yeah, but it's not cool enough.
It's not cool enough. So we're going to use one of the latest features we've got in 3.2 of Babylon.js that we shipped recently, is a glow effect. And if I'm pressing a button,
that's a lightsaber.
And you see?
And the sound is here.
Yes, because we don't have the money to, it's sounds being done with my mouse. So, and I can obviously cut it down. You see? Very impressive.
Vroom.
So this sound is not part of the specification. You need me to have that. Let's see how to build that using the code.
We have the audio file of David doing the sound of the lightsaber if you want.
Yes, it's under common license. You can use that in
okay.
your project if you want to.
So are these objects you're reporting reusable? Do you have object pooling?
So the question is this object are imported and reusable using object pooling? Yes, the question is good, and the answer is yes. So by default, Babylon.js will do whatever it takes to make sure we reduce memory consumption and GPU consumption. So David mentioned the create instance, for instance, and here we are loading the lightsaber, and actually it's only loaded once and duplicated within instance so that they are exactly the same, and the GPU knows how to render multiple times a single object because they are exactly the same, only the position change.
So to switch the controller, first, you need to create the VR helper.
Enable interaction.
Enabling interaction. And then you've got an event that will call you back, saying that one of the controller is ready. So you need to check if it's the left or the right one, because maybe people just want to use one of the two available controller.
And that's future-proof. If we one day meet with an alien race where there are two left and one right, we don't know, that's going to work with Babylon.js.
Thank you for that.
It's clearly future-proof.
It wasn't in our script, but interesting. And then we've got support for various events that come from WebVR. So we are exposing WebVR event for you. And this one is simply switching on or off the glow effect. To switch the controller model is very simple. Yes, I know, we've got 4 minutes left. You need to attach the mesh to the controller. So I'm going to remove the previous one and attach a new one and make it visible. So
one line of code.
Very easy to do. Now let's see the final game together. So we've been playing to the game in 2D, and now what I've been doing is really I've been simply adding the code we've seen together in the 2D version of the game. And I'm going to switch in my VR world again. And now we can
get ready.
Apples.
Ready to player one. Then,
yeah,
whoa.
I'm very good at that, and I could play for hours. And I'm pretty sure I will become rich. But to become rich.
Yes, how can you become rich? Because it's a simple web page. And you want to put that on the store, right?
Yes, obviously. So let's talk quickly about PWA to end this
Because
session.
we mentioned at the very beginning, truly cross-platform. So it's not only the browser, it's also all the store app out there. And the question is, oh.
So I've put my game somewhere on you will have the link. So it's going to work in the browser, even in offline mode, using a progressive web app. So we've got session this afternoon about that to know more about that. So using Service Worker, I can have a complete offline capabilities. So it's going to download my 3D models, my JavaScript files, CSS. So it's ready to be used. Also, we have a manifest file that's going to describe how I should load my application. So for that, I'm going to show you the code of it using Visual Studio Code. First, there is a manifest file. The manifest file is going to
zoom a little bit?
Yes,
thank you.
Provide some detail about how should I display it. So standalone means I don't want to see the Chrome of the browser. So I want to behave like a native app in a way. You can have the background color. You can have also icons and a splash screen, so like an application. And finally, it's really interesting for game. You can specify the orientation also. So I want to force a landscape orientation of my web page. Now that I've got that, I've got also Service Worker. So Service Worker is really there it's a proxy between the page and the server. So it's going to download the different assets. And you see that it's ready for Oculus, for Microsoft, and generic. If I don't know the controller yet, I will provide a generic model. So it's going to work offline.
Yeah, because by default, Babylon.js will download the controller on demand. But as you want to make it work on offline mode, you have to have all of them locally.
I'm going to pre-cache. And my famous GLTF file. This has been generated on a website that's very useful named PWA Builder. You're going to provide detail on it. And it's going to build the service workers, the various icons, because it's really painful to generate the various sizes of the icons. And finally, I took Visual Studio to package that into a store app. So the only thing you need to do in Visual Studio is really to just specify in the manifest file, let's not do that because I want to show you to that, the URL of your PWA. What I've just added is this specific part in the manifest, meaning that I want to have a 3D icon available for my application also.
So your app, you will be on the store thanks to PWA. Wow.
Yeah.
This one?
Exactly.
And because it's an app store and you define this line, then there will be a specific 3D icon inside the mixed reality portal.
And now I should see somewhere
Yes, right
up
there.
my Apple. I should pay attention not to make you sick. And you see this is the launcher of my app, which is the same game we've seen together.
You click on it.
You see the splash screen. I can put that wherever I want. I could play in 2D because the controller has a mouse, or I can switch now in VR. And this game could be in the store, and I'm sure you will buy it for a lot of money because you want to help me becoming rich. And I can play obviously the same game in the very same way. This is transparent, and if I'm updating the game from my website, it's going to be updated also for the guys using the application.
Thank you, David. Perfect. So that's it. As a summary, try it. We have a booth. Come to see us. We have dedicated people to help you starting from scratch. If you have any question, we are available after the session, obviously, or on the booth anytime. We have wonderful business card with a wonderful logo, so you should not miss that. Please read the documentation. No, seriously. I spent ages writing the documentation, so please read it. You will be able to do exactly what David did here. If you go to aka.ms/build-webvr, it's going to be a complete article and a blog on about all that you did today.
And all the playground that we've shown you, the URL, you've got access to it on this specific site.
Yes, and if you do something about 3D with Babylon.js, just ping us on Twitter. We love to know about that. Thank you very much for your attention. Have a good build.